Okay, so what if now we do a chemostat with the Monod equation? KD is still 0, but what if the inlet has x in it, so x is not equal to 0? You'll see that it actually makes everything a little bit more complicated, because now UG and UNet are not really going to be D. Before it was D, but now it's not. Again, we just work with the formulas, and you'll see that it's not too bad. You won't be able to get equations as cleanly as before. The equations are going to be a bit more implicit in nature, but you can still solve for this without too much of a problem. Okay, so let's do this. Now, for the x balance, we'll have this okay, so UNet. Okay, good. And then you know that D equals F over V, so we can take that to the other. We can divide by that. I'm just moving this to the other side. And let's go back to this. Since we're ignoring KD still, we can just say UG equals UNet. Okay, for this one, what we can actually do is isolate to see what D is in terms of. Actually, we can isolate in terms of UNet as well. Let's do that. We can take the negative to the other side and put it inside of the parentheses, or the argument, I should say, and then we'll do that. Okay, that's not too bad. And then we have an equation in terms of D and UNet. What else could we do? We could do substrate, and it's the same as before actually, so I'll do this quickly. Okay. And then we simplify this. And since UG equals UNet, I can just say that as well. It actually looks like we can get an equation in terms of x. Oh, what else we could do? Let's not forget we have the Monod equation to work with. Okay. And what can we do? UNet is UG, so we can just plug that right in. So, yep. Okay. And we can isolate it in terms of S. We'll use this equation in a minute as well. And actually, what we could also do is, we could just use this as well, like before. You remember what we got before S is just oh, we can just work it out. Let's just work it out quickly. So now it's a little different because we can't say that, you know, the U's are D. They're not. But it's kind of similar to what we had before. Okay. So a bit above, we got this term. Here KD is 0, so we can just say this equal to each other. And we can actually substitute that in. So what was UG, net dx minus x naught. And that was over x. But actually, first let's think about this. Before I substitute this, and maybe we can simplify it a little bit. Let's see. It can be d1 minus x naught over x. So let me just substitute that in instead. There we go. That looks pretty nice. And what else do we have? We have some equations. But we can say that, yeah, this is an equation in terms of s, and we can find an equation in terms of x. So let's look back at the equations that we wrote. It's s, and we have x. And we see that it's actually a nice equation we could use. This looks nice. So what was u net and you think? So now we need to get an equation in terms of x. There's a few ways we can do this. I'm looking for the easiest way we can do that, because I know what it is off the top of my head, and if you look at this equation, you can figure it out really easy just using the stoichiometry. Since KD is 0, there is another approach we can take. So let's take another approach. From stoichiometry, since KD is 0, we can actually take this approach. It actually makes it really easy. The change in S over time is this over the yield coefficient. So then we can actually just do this straight from s naught to s and x naught to x. What happens, it'll be this. You'll get, this is actually a really easy way. We can also use one of the other equations above to do it, but since there's no KD, we can take this approach too, and we'll get this. And then what can we do? We can multiply that and put that inside of this. And logically it makes sense. It's the same as before. See, the amount of x that you make is just a difference of, like, it's just the s that you consume multiplied by the yield coefficient, the stoichiometric coefficient in this case here, and you add x naught to it now, so it's like this. Nice. And that's what you get. you might not be able to do this if you have a KD. If you have a KD, it ends up going into this, but it ends up becoming a lot more complicated. But anyways, and yet if you want, you could stick this back into the S, and it'll end up making it a lot more complicated. Let's see what happens. And then X is just the... Yeah, I remember what it was. It's this. Okay, so now that's your equation in terms of the substrate, and this is the case when x naught is not equal to 0. So the thing is that now it's like implicit in terms of S. See how it kind of gets a little bit more complicated? Like, you can't really isolate for S easily, but yeah, this is when x naught is not equal to 0, so that's, you can use this formula. As well as the bottom one. The bottom one is a lot easier to understand. See, now you just add x naught to the end of it, to what we got before. Out of curiosity, let's see if we set x naught to be 0, will we get the same equation as we did before? Like, you know what I'm saying? The equation where, the case where x naught is 0, can we retrieve that equation again? Let's see. So if you set x naught to be 0, the whole thing gets knocked off, and the whole thing gets knocked off, and you get S equals this. And then yeah, you get what you got before. So that means that yeah, we did a good job. Perfect. And then this one is really easy too. What if you set x naught to be 0? Oh look, we got what we got before. Perfect. So just use these equations, ignore the crosses. Use these equations if you get a weird problem where you get basically a chemostat with a Monod equation, but where x naught is not equal to 0. But here, remember that we ignore the cell maintenance coefficient KD. But everything else is fine, and yeah, use this, yeah, if you actually are given a problem where you're actually feeding product to the inlet. So anyways, yeah, if you get a weird problem, maybe this will be helpful. Hope you enjoyed this video.